We have already discussed it a bit, but there's a relation between triangles or right triangles and cosine and sine and so on. And that's because, as I mentioned earlier, if you have two triangles with the same angles, then the relations between their lengths are identical, right? So what is this? This is some arbitrary triangle, right triangle, A, B, and C, and I have put it in such a way that we have the right angle down here along the x-axis. Then I have put an S here. What is this S doing? Well, if S is 1, then it's equal to my original triangle right here. Look at my A has length 3, right? So if I take my S up to 3, I should get something that crosses this point here. I can take it up even further. Then I get this, right? So what is the point with this? The point is that the triangle that moves here is basically the huge triangle divided by this number down here. Okay, so I scale it by dividing by the length of this number. It can be very huge, it can be very small. But since the relation is always the same, we can see that cosine, the x-coordinate of this, must be equal to what? Well, this length should be 1, right? So if we want to scale this big triangle to be have the same shape size as this one, we should divide everything by c, right? If we divide everything by c, then this is a over c, and then we get cosine, right? So cosine is equal to a divided by c. What about sine? Well, it's the same story, only we want our triangle to look like this, right? And then we want the y-coordinate, which corresponds to the height here, after scaling with c. So sine of theta is b divided by c. If we divide this by c, we get 1. We should have 1 here. So we also get that this becomes sine of theta when we divide this by c. Now, the tangent of theta can be calculated in different ways. One is to say, well, we want it to be the y-coordinate of this, right? What should we scale this with to get this something of length 1? Well, we should divide the a by a, right? And what is the height then? It's b divided by a. So that would be our b divided by a is the tangent. Agree? And another way of seeing the same thing is by saying, well, we already know that to calculate tangent, we only need the sine and the cosine. So we could just have said sine divided by cosine. Then we would get b over c divided by a over c. Then the c's cancel, right? And then we end up with just b over a. The cotangent is, of course, just tangent inverse. So we reverse the order of the division here. A divided by b instead of b divided by a. The secant is one of the ways we could calculate the secant was to take 1 divided by cosine, right? So that becomes 1 divided by a over c is the same as c over a, right? And the cosecant was the same, only with sine, so that becomes c over b. You could also have made an argument here that it's, yeah, we can just do it for one of them. So the secant, for example, what is that? Well, we wanted it to be the length of this line, right? When this line down here is 1. So how do we get this line to be 1? We divide by a, right? And then what is this? Well, this is c over a. So that is what we get. That's another way of seeing the same thing. But basically, all you need to remember is sine and cosine. Then you can always calculate tangent, cotangent, secant, and cosecant.